Hello, I'm Dima. I am a PhD student in Cambridge, advised by David, who was just on the panel. And today I'm going to quickly talk about this very recent paper with some people from Redwood, Ryan and Fabian, who led this project, and also David. And the paper is stress testing capability elicitation with password locked models. So what is a password locked model? Password locked model is basically a model where if you give it a password in the prompt, which is like some pretty fine thing, could be anything really, then the model would behave normally and would display its normal capability. Whereas if you don't give it the password, the model would not display this capability. So basically, it's like a language model with some capability locked behind a password. And we train these password locked models via either fine-tuning a pre-trained model to imitate a weaker model when there is no password and behave normal otherwise, or just from scratch on a toy task. And these password locked models are a pretty nice test bed for capability elicitation. In particular, they're nice because with this password locked model, we know that the capability is definitely there, so we sort of know what to aim for. And we definitely know when our elicitation process succeeded or failed. And most of our paper is actually just testing different variations of fine-tuning at how good are those at unlocking the password locked models. So for supervised fine-tuning, we find that you need very, very few samples to unlock these models. In particular, here you can see that for the math data set, 8 examples already gives you most of the original locked performance, which is insanely high sample efficiency. Whereas for MMOU, it's a bit more because, MMOU is this multiple choice data set. So each individual sample gives you basically just one token of information. We also find that unlocking generalizes super well. So if you have, if you locked only some, or if you are unlocking only some subset of the distribution that's really easily identifiable, then the other subsets are going to unlock as well. Similarly, if you're unlocking not exactly using the samples how your model would normally do things, so you use samples from a slightly different but also good model, that also totally works and unlocks the model quite well. The place where things are not as rosy but still are okay is reinforcement learning. So sometimes we don't have access to nice high quality demonstrations we need for the supervised fine-tuning unlocking. And here, unlocking success is really highly dependent on how good is the behavior of the model when you don't give it the password. So this locked behavior. And basically, does that locked behavior give you enough signal to for the RO process to pick up and reinforce the right kind of behavior? So here we had this model, which was, I think it was DeepSeek 7B on math, which is pretty good at math. And then the password locked behavior, so when there is no password, the model just imitates either PFS 7B or 1B or 400 million. And for the stronger locked behavior, basically we can unlock the model pretty well. All these different colored lines are the different RL algorithms. But if the model basically doesn't give you much signal, then it's just not going to work very well, the unlocking process. We started this project mostly thinking about sandbagging, which is this hypothetical failure mode where the model might strategically act below its true capabilities. And for instance, just don't show the maximum possible level of some dangerous capability for some reason, or maybe not fully critique another AI's outputs. This is on top of just regular capability elicitation being quite important. And the takeaway from this work is actually fine-tuning is really, really strong, and it unlocks these password locked models very easily. And so model sandbagging, I think it's a slight update against that being a real big issue, especially if we have good high quality demonstrations, but even in RL. Thank you.